Okay, so today we'll be discussing wind turbine and later on hydrogen power. So what are wind turbines? Wind turbines work on the same principle. Simple principle. Instead of using electricity to make wind like a fan, it does the opposite. Wind turbines use wind energy to make electricity. Wind turns the propeller like blades of a turbine around the rotor, which spins a generator, thus creating electricity. You've probably seen one of these so-called wind turbines on what we call a wind farm. Vast open fields where wind is constantly blowing on them, making them rotate. Here is a cross-sectional view of a wind turbine. You can see here the main rotor, the blade, which the blade's attached to. It's connected to a gearbox. You've probably seen these things spin very slowly. Thus, we need a gearbox in order for the slow rotation to be converted properly into the fast needed RPM of a generator. Could you please read the first two slides, the first two bullets?
Okay, so wind turbine. A wind turbine is a type of renewable energy that harness the power of wind to produce electricity. The basic idea is that wind turbine uses the rotor, which with attached blades to collect the wind's potential and kinetic energy. Wind turns the blades, which spins a shaft that is connected to a generator, which results in generation of electricity.
Okay, thank you. Now, the term wind energy and wind power both describe the process by which the wind is used to generate mechanical power or electricity. This mechanical power can be used for specific tasks, such as previously in the past, grinding grain or pumping water, or more recently, turning a generator, which converts this mechanical power into electricity. Here we have the basic parts of a wind turbine. You see here the wind coming into the rotor and the blades, making it spin. We'll discuss later why the wind direction makes these blades spin. You can see here the low speed shaft driving a gearbox in order to give the appropriate RPM for the generator. You have a controller controlling the what we call anemometer. This anemometer determines the wind direction. This controller then controls this what we call yaw drive. This makes the whole wind turbine spin in the direction opposing the wind direction in order for these blades to rotate. Okay. Could you please read the blade, the part of the wind turbine?
So the blade is the part of that rotates due to the force it catches from the wind. So it is connected to the low speed shaft via the hub. So the low speed shaft is connected to the gearbox, and the gearbox to the generator. Once the blade rotates, it causes the rotation of generator, thereby generating electricity. So most wind turbines consist of 3 blades for maximum efficiency.
Okay, thank you. Now, a wind turbine turns wind energy into electricity, right? Using the aerodynamic force from the rotor blades, which work like an airplane wing or helicopter rotor blade. When wind flows across the blade, the air pressure on one side of the blade decreases. The difference in air pressure across the two sides of the blade creates both lift and drag. The force of the lift is stronger than the drag, and this causes the rotor to spin. The rotor connects to the generator either directly or through a shaft and a series of gears that speed up the rotation to allow for a physically smaller generator. This translation of aerodynamic force to rotation of a generator creates electricity. Now, the blade design plays a very important role in the generation of electricity, since that's the part which spins and gets spun by the wind energy. Could one of you please read the definition for blade design?
Okay, so blade design. To produce an amount of power, wind turbine blades generally need to be large and tall. It is shaped to generate the maximum power from the wind at the minimum cost. Improvements in the design has produced new wind turbines, which are more compact, quieter, and generates more power from less wind. Its length vary at around 50 meters with 107 meter currently the longest from Siemens Gamesa.
Okay, thank you. So you can see why these blades are so long in order to collect more kinetic energy from the wind, more surface area, meaning more wind energy can be used to drive the rotor. Here we have the longest wind turbine blade in the world. You can see that's actually hollow in order to make it lighter, to be able to be spun more easily by the wind. Now, could you please read the blade design again? Definition of the blade design.
So one of the blade design is airfoil. So airfoils is the cross-sectional shape of the blades that determines its aerodynamics. So they are key to blade design. So this airfoil design allows the blade tips of a wind turbine to move faster than the wind is moving. So thus generating more power and higher efficiencies.
Okay, thank you. Now, if you notice, if you see this cross-sectional area of such a blade, it's reminiscent of what we see in a airplane wing, wherein when air hits this, it produces a pressure differential, making the air that goes on top of it flow faster, while air that goes below it slower. But in order for these to avoid such vacuums, what we call the air that goes on top and the air that goes on the bottom must meet at the rear of the wing at the same time. So the air that goes on top must go faster. This creates what we call lift and drag. Here we have a different airfoil family for medium blades and thick airfoil family for large blades. We can see that there are actually very different designs for the blades. These translate to different efficiencies for different wind speeds and different length blades. Now we have blade aerodynamics. Could one of you please read this?
Okay, so blade aerodynamics. Wind turbine blades work by generating two aerodynamic forces, lift and drag. This is due to the wind and their airfoils. Lift force is perpendicular to the airflow and is in line with blade rotation. Drag force is in line with the apparent wind direction, which is in opposite of the blade motion. Drag increases in proportion to the frontal area of an object facing the wind.
Thank you. So what I was talking about before, we see the wind flow produce lift and drag. Because when the wind hits the wing or the blade in this case of the turbine, it produces a pressure difference between the top and bottom sides. We get this pressure difference from the what we call Bernoulli's principle, wherein the top wind actually accelerates faster than the wind from the bottom. Or we can look at it at a different way using vectors. The lift and the drag is the component vector of the kinetic energy from the wind. Here we see the resultant force from the relative wind. You can see the lift is actually a component vector from this resultant force. Because when wind hits this wing, it actually goes down, right? It goes down and goes right. Now, from Newton's first law of motion, is it the first law? One of Newton's laws of motion, physics, there is an equal and opposite reaction. Thus, there is a force that goes up and right. So one of you please read again the blade aerodynamics bullet.
So blade aerodynamics. So another thing that the airfoil is able to bring is for the blade to attain difference in pressure on both sides. So the most curved sides, or we may say the convex side, generates low air pressure, while the high pressure air pushes on the less curved side. So, or we may say the side will with slightly concave part. This is the actually the reason for blade rotation.
Okay, so thank you. But here's a better diagram for what I was talking about before. You can see here that when the wind hits this curved blade, it actually forces the wind that goes on top of it to go faster. Now, when the wind goes, we can think of the wind as a fluid, right? When it goes faster, it generates a lower pressure compared to the wind on the bottom. When the wind on the bottom stays at the same relative velocity while the wind on the top gets faster, this creates a high pressure from the wind at the bottom, thus creating lift. This is what the general principle for the wings on an airplane. But for our wind turbine, this generates a rotation because the angle of the blades make them rotate above the point of the rotor. Let's see more diagrams. One of you please read.
Okay, so blade wind orientation. Here is now the question. Based on the figure, illustrating the optimum angle of attack. Which part of the blade is the leading edge and trailing edge, front and back?
Okay, thank you. You have more question. What will be the rotation of the blade? Is it pushed to the side that has more curve or pushed to the side that has less curve? We can see another form of the lightening to maintain structural integrity of the blade while reducing the weight of the blade. The photo shows the front side and back side as well as the leading edge and the trailing edge of the blade. Okay, can one of you please read again?
So in addition to its design, twisted and tapered blades further enhance its aerodynamics. So with the combined effect of twisting and tapering, the blade along its length improves the angle of attack, increasing speed, efficiency, and lift while reducing the drag. I mean.
Thank you. Now here's now the question. Based on the previous slides, what number of blades is the best design in consideration of all the factors in construction and operation of a wind turbine? We already know that the rear of the blade is curved more than the front. This varied shape causes a pressure differential when the air moves across the blade, which is what causes the blade to move, right? Because of the obstruction of the blade, air moves at a faster velocity behind the blade than in front of it. This is what sets the rotation of the blades in motion. Engineers must consider speed and drag in designing the blade to ensure the highest level of efficiency. For example, if too much drag is created by the obstruction of the blades, the power yield will be a lot lower. If not enough drag is created, the blades could move too quickly, causing them to break the sound barrier. The rule of thumb are the fewer blades, the better, since there will be less drag and an increase in efficiency. The number of blades increases the torque and reduces the optimum rotation speed. Having fewer blades reduces drag. Okay, could one of you please read the one blade wind turbine?
Okay, so one blade. Because of the decreased drag, one blade would be the optimum number when it comes to energy yield. However, one blade could cause the turbine to become unbalanced and this kind is not a practical choice for the stability of the turbine.
Right, thank you. So now, because there's only one blade, right, there would be reduced drag, thus meaning that it would be the most efficient when it comes to energy yield. But because of the laws of physics, this would be in imbalance because there is a weight on one end, yet there is nothing on the other, making this very unwieldy and unbalanced. Now, what about two blades? Could one of you please read?
So two blades. At first glance, two-blade turbine seems like the optimal configuration for a wind turbine. So perfectly balanced and one blade less than a three-bladed turbine. They will generate less drag. So why aren't all turbines made with two blades? So the answer for that is it has troubles in yaw. Yaw is when its head turns to face the wind. Due to an effect called gyroscopic precession, when a two-blade turbine yaw, it creates a wobble as the blades go from the vertical plane to the horizontal plane, so which places additional stresses on the mounting bearings. So wearing them down faster.
Yes, thank you. So now we see why we don't actually use two blades, despite it being the more obvious answer or solution to the one blade problem of imbalance. We have what we call the gyroscopic precession in the two blade design, which causes premature wear in the bearings, making them need more maintenance in the long run. Now, for more than three blades, any number of blades greater than three would create greater wind resistance, slowing the generation of electricity and thus becoming less efficient than a three-blade turbine. For these reasons, turbines designed with blades are ideal compromise between high energy yield and greater stability and durability of the turbine itself. Thus, three blades are used. Okay, so could one of you please read this?
Okay, so blade tilting mechanism. According to the wind speed, the relative velocity angle of the wind also changes. A blade tilting mechanism is a sensor coupled to parts of the wind turbine which tilts the blades and guarantees a proper alignment of the blades with the relative velocity, so that its position is always at the optimum angle of attack.
Okay, so thank you. So now, wind doesn't always have the same velocity and relative angle of attack. So relative to the blades of the wind turbine, right? So now the solution to this is what we call the blade tilting mechanism, which optimizes the blades so that they are always within the optimum angle of attack. So engineers call it, for the wind to generate maximum energy. Okay, so could one of you please read the nacelle, I believe it's called?
So nacelle, the housing at the back of the blade which contains the slow speed shaft, gearbox, generator, and other small parts inside it.
So this is another important part of the wind turbine. This contains the gearbox for the gear increase ratio for the generator and various other small parts. Okay, so finally, we have a gearbox. Could one of you please read?
Okay, so gearbox. The component which converts the slow rotation of the slow speed shaft into faster speed. This is needed simply because the rotation of the slow speed shaft is usually not enough for a generator to achieve a grid quality voltage output. Most generators need to be turned at 1,500 RPM for 50 Hz and 1,800 RPM for 60 Hz. In no way it is feasible for a turbine blade to move that fast.
So thank you. So now we see that the rotor or the wind blades actually rotate at a very slow RPM, because to reduce the imbalance, if they were to be rotating at the speed in which the generator would be operating at maximum efficiency, which is 1800 RPM for 60 hertz in our case, then they would be prematurely destroyed or prematurely wear out, requiring more maintenance again. See here, it states that it is not feasible for a turbine blade to move that fast. So we use a gearbox to step up that gear ratio for the 1800 RPM required. A common ratio of 90:1 with a rate of 16.7 RPM input from the rotor to 1500 RPM output to the generator. Okay, so could one of you please read this?
So direct drives or gearless. So in a direct drive turbine, there is no gearbox. The main shaft spins the generator directly, causing it to spin at the same speed as the turbine blades. Comparing to gear type, the slow rotation and decrease in moving parts of PMDD generator reduces fatigue and stresses on the turbine, resulting to reduce noise and vibration, longer lifetime, and lower cost of maintenance.
So thank you. Now, if we have geared wind turbines, we also have direct drive turbines or gearless wind turbines. This makes the rotor or the wind turbine itself directly coupled to the input of the generator. Of course, since the wind turbine needs to be rotating much faster compared to a geared wind turbine, this causes much more wear on the various moving parts inside the wind turbine, making it cost more in terms of maintenance. An important fact is that due to the wind inconsistency, the gear-type turbines often operate at partial loads. The efficiency of PMDD generator excels even in these conditions because it continues working nearly to nominal values. This design makes it suited even in offshore wind application. Okay, so could one of you please read?
Okay, so direct drive or gearless. One main disadvantage of PMDD is that to make up for its slower rotation, more magnets are added to create the required frequency and power. This increases the diameter of generator, which makes it larger and often heavier than geared type wind turbine. Another thing is that the additional magnet being used in this type is made up of neodymium, which is expensive.
Okay, so thank you. So instead of modifying the output RPM of the wind turbine, the direct drive wind turbines modify the design of the generator into a, let's say, specialized type, specifically for the speeds that wind turbines generate. However, this presents a upfront cost, the challenge of materials, in this case, lots of neodymium magnets, very expensive neodymium magnets, might I add, into the design of the generator. And it also makes these direct drive wind turbines much larger. Now, the cost and weight of the direct drive turbines have prevented it from presenting major competition to gearbox turbines until recently. But other experts claim that direct drive technology will eventually become the dominant one, since the gearbox wind turbine is almost at its maximum efficiency point, while the PMDD generators have more possibilities for improvement. Yes, so because the geared wind turbines have gears, these present mechanical losses in the energy generation. And so the efficiency at which these geared wind turbines generate electricity has what we call, how do I say, stagnated or plateaued. So the future possibly would be direct drive gearless, depending on how the generator is designed. So now we have the brake in a brake system in a wind turbine. It's a protective device coupled with sensors which automatically stops the rotation of the blades whenever it detects activities that could harm the system during operation, such as very high wind speed, vital parts not working, and maintenance in power lines. Now we have the yaw system. Could one of you please read?
So your system is a sensor-equipped mechanism consisting primarily of yaw motor. So yaw drives and others. Its function is to automatically rotate the nozzle on the top of the tower so that the sets of blade is facing the wind directly at all times. It detects its proper direction through the electronic information being fed by the wind vane located at the back. This ensures that the wind turbine is producing the maximum amount of electric energy.
Thank you. So now we have the yaw system. I said before, it senses where the direction of the wind is coming from and makes the wind turbine turn into that direction, thus making it efficient, much more efficient. Instead of it, say it was 60 degrees off from the direct wind direction. So now we have another part, which is the tower. One of you please read.
Okay, so tower. Wind velocity increases at a higher altitude. This means the taller the tower, the greater electricity it can produce. Majority of wind turbines are supported by conical tubular steel towers with a height of usually 75 to 110 meters, or 250 to 370 feet, depending on the blade's diameter. The tallest is steel for the completion in the mid of 2022, which is 280 meters, to be installed at the test center in Western Jutland, Denmark.
So thank you. Now, if you think about how wind is generated, which is like the uneven heating of the atmosphere from the sun, wherein the colder air goes down while the hotter air rises. We can see that the wind is greater the higher you go. So thus we make these wind turbines at a higher elevation. This also presents a good safety feature for these huge wind blades and a very stable, very robust mounting system for the wind turbine itself. Now we have here the diameter ratio for the wind turbines. As you can see, as the decades went on, the blades of the wind turbines rather, got larger and larger, making them more efficient at generating electricity. Now we have the ideal locations for the wind turbine placement. The best places for wind farms are in coastal areas, at the tops of rounded hills or plateaus, open plains and gaps in mountains or valleys, or just generally places where the wind is strong and reliable. Some are offshore. So to be worthwhile, there should be an average wind speed of around 25 kilometers per hour. Now we have the advantages and disadvantages of the wind turbine. Could one of you please read the advantages?
So the advantages of wind turbine. So wind is free. Wind farms need no fuel. So the second one produces no waste or greenhouse gases. So the third one is the land beneath can usually still be used for farming. And the last one is a good method of supplying energy to remote areas.
So thank you. So now, wind is free. Yes, it's actually a byproduct of the nuclear reactions present from the sun. So it's what we classify as renewable energy. Produces no waste or greenhouse gases, since it only uses the kinetic energy of the air to turn a rotor and the generator. The land beneath can usually still be used for farming. If you notice before, the towers of these wind turbines are actually take up a very small small square area of land. Thus, the land beneath can still be used for farming. Since these wind turbines are also very tall and generally do not interfere with the land around them. It's a good method for supplying energy to remote areas. Yes, since what we classify as remote areas would be those in like offshore, coastal offshore areas, such as mining rigs. We can install wind turbines there on the sea, since there's also wind energy there. Now, the disadvantages, could one of you please read?
Okay, so for the disadvantages, so the wind is unpredictable. It changes speed throughout the day and from season to season. Suitable areas for the wind farms are often near the coastal area, where the land is expensive, can affect television reception on nearby places.
Oh, thank you. Now, as with solar energy, the wind is unpredictable. It doesn't stay like in a specific velocity throughout the day. It changes from day to day, from season to season. It can be very fast right now, and just a minute later, it could be very slow. The wind is generally just very unpredictable. That's why we designed various methods to ensure that the losses present from the unpredictability of the wind is mitigated. Now, as we mentioned before, the suitable areas for wind farms are near coastal areas. However, land there is very expensive. So we often just see wind farms in like open valleys or plateaus, flatlands, wherein there is no obstruction for the wind. Now, it can affect television reception on nearby places. This doesn't really apply to us right now anymore. However, since they are very large and they are made of metal, they can actually interfere with the reception of other more recent signals, such as cell phone signals and Wi-Fi signals and the like. We have the large wind farm, the Gansu wind farm. Could one of you please read?
So the Gansu Wind Farm. So the Gansu Wind Farm project, or Juikan Wind Power Base, is a group of large wind farms under construction in western Gansu province in China. So in 2008, construction began on a 750 kilovolts alternating current. So alternating current power line to carry electricity from the wind farm. And construction of the wind farm themselves started in August 2009. So in November 2010, officials announced that the completion of the project's first phase, involving the installation of over 3,500 wind turbines with an installed capacity of approximately 5,160 megawatts. So it has an estimated cost of 120 billion Chinese yuan, or 17.5 billion in US dollars. So the project is being built by more than 20 developers.
Oh, thank you. Here is a picture of the Gansu wind farm. You can see that the placement of these wind turbines are cascading. They didn't just place them here randomly. Look at the placement. They're in a line. They face the optimum direction of the wind. So now we have the Burgos wind farm. Burgo. Could one of you please read?
Okay, so Burgos Wind Farm. The 150 megawatts Burgos Wind Farm is the largest wind power project in Southeast Asia, located in Burgos, Ilocos Norte, Philippines. The estimated cost for the construction of the wind farm was 450 million US dollars, which was completed in 2015. It is located within a 600-hectare site. The facility consists of 50 wind turbines, each with a capacity of 3 megawatts, generating electricity to the Luzon grid. Each wind turbine rests on a tabular steel tower, has a 75-meter hub height, and a 90-meter rotor diameter.
So thank you. Now we move on to hydrogen power plants. So hydrogen energy involves the use of hydrogen and/or hydrogen-containing compounds to generate energy to be supplied to all practical uses needed with high energy efficiency. Overwhelming environmental and social benefits, since hydrogen energy, the byproduct of using hydrogen energy is oftentimes just water, as well as economic competitiveness, since the only economic cost of hydrogen energy would be the production of hydrogen energy itself, which is actually very easy to do, as we will see later. Hydrogen energy conversion systems are expected to become the choice of future energy systems. It is possible to produce hydrogen from sustainable and renewable sources. Okay. So now we ask the question, what is a hydrogen power plant? One of you please read the first 3 lines, 3 bullets.
So a hydrogen power plant is a concept designed for a new widespread source of electricity. Essentially, it is a facility which uses hydrogen to produce electrical energy. So it is being proposed that a large facility, not unlike a nuclear power plant in appearance.
Okay, so hydrogen power plants use hydrogen to generate electricity. They generate this electricity using the electrochemical reaction used from hydrogen molecules and oxygen molecules. The cost involved with obtaining the hydrogen means the overall cost of hydrogen-based electricity will be greater. So the cost of generating electricity based on hydrogen is dependent on the process at which we obtain pure hydrogen. Now, first, we must discuss the inner workings of a battery. A battery is a device that stores chemical energy and converts it into electrical energy. Could one of you please read the next lines?
Okay, so the chemical reactions in a battery involve the flow of electrons from one material to another through an external circuit. The flow of electrons provides an electric current that can be used to do work. So next, to balance the flow of electrons, charged ions also flow through an electrolyte solution that is in contact with both electrodes. So different electrodes and electrolytes produce different chemical reactions that affect how the battery works, how much energy it can store, and its voltage.
Okay, so we see from this diagram of the simple diagram of a battery. Here we have the anode, the negative side, and the cathode, the positive side. You can see there is an imbalance of charges from the anode side. The anode wants to give electrons to the cathode side. And when the anode gives electrons to the cathode through a load, we have a flow of electrons. This flow of electrons is what we define as electric current, right? Now, to offset the flow of electrons, since if the anode just gives electrons to the cathode, then there would be another imbalance in the anode. It also gives positively charged ions through an electrolyte here to the cathode as well, positively charged ions through an electrolyte solution. Now, as the anode gives more ions and electrons to the cathode and thus through to the load, it gets discharged. This chemical reaction can be obtained using various materials, combinations of materials, and is still being researched to this day. Okay, so an electrochemical battery, here's a proper definition, produces electricity with two different metals in a chemical substance called an electrolyte. On one end of the battery, it is attached to one of the metals, and the other end is attached to the other metals. A chemical reaction between the metals and the electrolyte frees more electrons in the metal than it does in the other. Thus, there is a flow of electrons here. Now we move on specifically through hydro fuel cells, which is another form of a battery. Hydrogen fuel cells produce electricity by combining hydrogen and oxygen atoms. The hydrogen reacts with oxygen across an electrochemical cell similar to that of a battery to produce electricity, water, and small amounts of heat. As I said before, the only byproduct of these hydrogen fuel cells would be water and a small amount of heat, thus making it environmentally safe and friendly. Many types of fuel cells are available for a wide range of applications. Okay, so now we have here the oxygen coming from the air, which enters the fuel cell. Now there is a hydrogen fuel here that comes into the fuel cell again, and they represent from the previous definition, two different kinds of metals. These two gases are the different kinds of materials which react differently with the proton exchanging membrane here and produces a flow of current through the load. Now, could one of you please read this?
So a fuel cell uses the chemical energy of hydrogen or another fuel to cleanly and efficiently produce electricity. So if hydrogen is the fuel, electricity, water, and heat are the only products. Fuel cells are unique in terms of the variety of their potential applications. They can provide power for systems as large as a utility power station and as small as a laptop computer.
Thank you. So we can see here that the hydrogen fuel cell cleanly produces electricity, not unsimilar to what we see in a battery, the only byproduct being water. So the only limiting factor on this kind of battery would be the amount of hydrogen that we have in stock and how much we can produce it at a given time. Now, how does this work specifically? Well, fuel cells, as stated before, work like batteries. They do not run down or need recharging, however. They only need a steady supply of hydrogen fuel and oxygen. They produce electricity as long as these fuels are supplied. Now, we move on to finally hydrogen power plants and the inner workings of a hydrogen power plant. Here we have a electrolyzer. This electrolyzer is what produces hydrogen gas. We take in water and we take in a source of electricity, in this case, renewable energy from the grid, and run an electric current through the water. Now, when we run electric current through the water, it separates the hydrogen and the oxygen atoms. The hydrogen atoms bubble up and go into the air, since the oxygen atoms get left behind and are denser. So we pump this hydrogen gas into a compressor, which compresses it for storage in a tank, which then gets fed into the hydrogen fuel cell. This hydrogen fuel cell produces the electricity, which feeds the green energy to the grid. Okay, so one of you please read this first box.
Okay, so how it works. A fuel, such as hydrogen, is fed to the anode, and there is fed to the cathode. In a hydrogen fuel cell, a catalyst at the anode separates hydrogen molecule into protons and electrons, which take different paths to the cathode. The electrons go through an external circuit, creating a flow of electricity.
So thank you. You can see here now the inner workings of the hydrogen fuel cell. Since large tanks of liquid hydrogen will feed into thousands of hydrogen fuel cells, the fuel cells themselves are solid structures containing an electrolyte fluid and two terminals, not unlike batteries. Okay, so that's all. Thank you for listening.
Oh, thank you.